Welcome, curious minds, to another deep dive. Today we're embarking on a truly distinctive journey. We're using rhythm and lyrics to explore the intricate world of AI concepts and, well, the gnarly challenges researchers face every day. Our guide, it's this fantastic concept album, Data Roots, Rasta Rhythms, which we're using as our main source material for this deep dive. Our mission today is really to pull out the key insights from 5 amazing tracks: Data Hunger, Tweakin the Tokens, Mixture of Experts, Smooth Divide Right, and Coding on the Island. Each song, believe it or not, gives us a surprising, sometimes funny look right in the heart of AI development. It's a lyrical peek at the sheer effort and, the clever thinking involved.
Yeah, it's actually quite remarkable how well these songs capture the intricate, sometimes really gritty realities of building these systems, from that very first bite of data you collect through all those relentless cycles of refining things right up to the big vision of deploying it globally. This album tells a story that I think many people in the field will deeply connect with. And we're excited to sort of pull back the curtain on those insights for you, linking the music to what's happening at the cutting edge of AI research and engineering right now.
Okay, great. Let's unpack this, starting with the absolute cornerstone of any AI system, data. We're diving straight into the track, Data Hunger, and wow, the lyrics immediately paint this vivid picture of this foundational, almost insatiable need. It's not just about having some data, is it? It's more like this voracious, ongoing demand. Often the first major hurdle, the song lays it out, singing, "Need more data, the pipeline's flowing," stoking the train and said, "Keep it growing, trillions of bits in a swirling sea, models searching for clarity." And it also highlights how neurons spark. They twist and they turn, always reaching for what they can learn. Oh, the bytes, they stack and they churn. What jumps out at me isn't just the sheer quantity, but this almost biological urge for information that it describes.
Right. And what's truly insightful here is how this data hunger isn't just a catchy phrase, it's a fundamental challenge. It's driving some of the most advanced research in AI today. Think about it. Large language models, for instance. They've ingested petabytes, literally petabytes of text and code. But the thirst isn't just for any data anymore. It's for diverse data, high-quality data, multimodal data. That's the key now. We're actually seeing bottlenecks, not just in sheer volume, but in getting data that, accurately represents diverse human experiences, or data that can effectively bridge vision, language, audio, and all this while navigating increasingly strict data privacy regulations. That's a huge factor. So it raises these critical questions. Do we even have enough good data for truly robust general AI? Or are we kind of hitting a wall? And this has led to an explosion in research on things like synthetic data generation, where AI actually creates its own training examples or advanced data augmentation techniques to intelligently expand the data sets we do have. It's this endless quest, just like the song says, "Don't feed the machine. It's never done. It chases knowledge under the sun." And then there's the environmental impact too, right? These massive data centers. It becomes a very real concern when you consider this relentless consumption. So, see, data hunger isn't simple. It's complex. It's a multifaceted engineering and ethical dilemma.
That's a fascinating layer, because often we just think more data equals better AI. Simple as that. But you're highlighting the type of data, the cost, both financial and environmental, and the sustainability of that hunger. It really pushes beyond just feeding the machine to asking, okay, what are we feeding it and at what actual cost? So, all right, once our AI models have gorged themselves on data, and we've done our best to curate these enormous pipelines, what's next? It's rarely perfect first go, I
Yeah,
mean.
definitely not.
This brings us neatly to our next track, Tweakin the Tokens, which perfectly captures that relentless, often painstaking process of refinement. It's like the digital version of an artist, constantly honing their craft, but, on this colossal algorithmic scale. The lyrics are remarkably honest, I think. My model's crying out for a fix, tweaking the talking, always be tweaking, chasing the answers, caught, never sleeping, lost in the loops, the cycle's repeated. It just perfectly illustrates that continuous, sometimes exhausting nature of AI development. Every tiny improvement feels hard-won.
Exactly. And this concept, tweaking the tokens, it's absolutely central to the very essence of machine learning optimization. It refers to that iterative adjustment of a model's vast number of parameters, the weights and biases they dance in my head, as the song so brilliantly puts it. We're adjusting those to minimize errors and boost performance. But when you're dealing with models that have billions, maybe even trillions of parameters, well, this isn't just turning a simple dial. No, we're talking sophisticated optimization algorithms. Things like Atom or SGD with momentum, each has its own learning rates, decay schedules, all trying to navigate what we call a non-convex optimization landscape.
Non-convex.
Yeah, imagine a huge mountain range covered in dense fog. We're trying to find the absolute lowest valley, that's the global minimum error, but there are countless smaller valleys, local minima, that can easily trap our search algorithm. It gets stuck. So techniques like Bayesian optimization or gradient-free methods, they're used to try and find the best set of hyperparameters. Those are the settings that guide the search itself. But it's incredibly computationally intensive and often requires as much intuition and experience as pure science. This constant patching the flaws in the dead of night, as the song says, that's what allows models to go from just functional to genuinely high performing, always chasing that epiphany come like the morning light. Even though, realistically, perfection's just a dotted line, the pursuit is perpetual. And the compute needed for just one round of this hyperparameter tuning can be absolutely immense.
Wow. That analogy of the foggy mountain range, trying to find the lowest valley, that really brings it to life. It makes you realize why researchers are never sleeping, trying to untangle these incredibly complex landscapes.
Yeah.
It really sounds like a blend of like brute computational force and very intelligent strategy, always pushing to squeeze out that last bit of performance.
That's a good way to put it.
Okay, now, imagine you've tweaked your model to within an inch of its life, but it's still not quite robust enough for the full complexity of the real world. Or maybe it struggles with really diverse tasks. That's where our next track, Mixture of Experts, introduces a really powerful architectural solution, something that goes beyond the single monolithic model approach. The song observes quite wisely, one model stands, it shines so bright, but no long star can light the night. A team together, they take the fight. It immediately sets the stage for a more collaborative approach, right? Recognizing the limits of just one entity.
Yes, and this raises a really important question. What does a mixture of experts, or MOE as it's often called, actually do? And why is it suddenly such a breakthrough in many large-scale AI systems, especially large language models? Essentially, instead of having one massive model trying to handle everything, you have several smaller, specialized models. Those are the experts. And each one handles different parts of the problem. There's usually a router network, too, which determines which expert, or maybe which combination of experts, is best suited for any given input.
Ah, okay. Like a dispatcher.
Exactly like a dispatcher. So if you ask a complex question, the router intelligently sends parts of that task to the most appropriate experts. They work in harmony, as the song describes it. And the real beauty of MOE and why it's gaining so much traction is that it allows for models with vastly more parameters to be trained, but without a proportional increase in the computational cost during inference.
How did that work?
Well, while the total parameter count may be enormous hundreds of billions, even trillions, only a fraction of those parameters are actually active for any given input. It's called sparsity. This sparsity makes them highly efficient for certain tasks and enables scaling we couldn't really achieve before. Models like Google's Switch Transformer, for example, have leveraged MOE to get to these huge parameter counts. It really is like a dance of knowledge so divine, allowing them to solve the puzzle line by line by combining their collective wisdom, recognizing that, no single voice can sing the tune. It takes a chorus under the moon.
That's a crucial distinction then. It's not just throwing more models at it, but using them more smartly.
Yeah.
So it's less about brute force compute and more about rethinking the architecture itself for specialization and efficiency.
Precisely.
But what are the practical challenges? Surely coordinating all these experts isn't trivial.
Oh, definitely not. While the benefits are huge, implementing MOE efficiently brings its own set of headaches. Load balancing, for instance. You need to make sure all your experts are being used effectively, right? You don't want just a few getting overloaded while others sit idle. The router network itself needs very careful training. If it sends inputs to the wrong experts, you can get completely nonsensical outputs. And while inference, the actual running of the model, can be more efficient, the distributed nature of MOE models can add complexity. Things like memory management and communication overhead between different hardware accelerators. It's a powerful tool, no doubt, but it requires some sophisticated engineering to really make it shine.
Right. It's like having that dream team, like you said, but also needing an incredibly smart project manager to make sure everyone's contributing optimally. It's a fascinating architectural pattern, and it echoes problem solving even outside AI, doesn't it?
It really does.
Okay, let's pivot slightly. AI models often face situations where data is just sparse, or maybe an event is so rare we just don't have enough examples to make reliable predictions. How do you handle that? How do you make robust predictions then? Our next track, Smooth Divide Right, gives us a fascinating insight into dealing with this kind of uncertainty. It reminds us that the real world isn't always neat and tidy, especially with things that don't happen very often. The song starts by lamenting, some events count, they come up shy, not enough data, I'm wondering why the wrong sort's here, a tangled knot, This speaks directly to that common problem. Rare events, insufficient information, where just counting things can be really misleading or even give you zero.
Exactly. And what's fascinating here is how the song uses probability as my guiding light in these tangled knot situations. Now, Smooth Divide, right, well, it's a poetic phrase from the album, really encapsulates a family of statistical and machine learning techniques we call probability smoothing. When your raw data count for an event is very low or even zero, a naive probability estimate would also be zero, and that can be disastrous for a model. Think about natural language processing. If a specific sequence of words, say an n-gram, has never appeared in your training data, its raw probability is zero. That would mean your model could never generate or understand that sequence, which is obviously not good.
Right, it breaks things.
It does. So probability smoothing techniques address this by, well, quite literally smoothing the probability distribution. Techniques like Laplace smoothing, for instance, it's a simple one. Basically adds a tiny pseudocount to every possible outcome. This effectively gives even unseen events a very small but non-zero probability. More sophisticated methods like good Turing smoothing work by reallocating some probability mass from the events that happen frequently to those that are rare or unseen based on the frequency of frequencies.
Okay, that sounds clever.
It is. It helps tame the chaos in the numbers, providing those patient whispers soft and low, guiding me where the answers go. Even when the noise is loud, the signal fade. It's all about making sure that predictions for low-frequency events are still sensible, not overly volatile. It prevents the model from making these overly confident or just plain wrong, zero probability guesses when the data is thin.
So it's essentially about introducing a bit of informed caution, maybe like a Bayesian prior, if you will, when the raw data isn't telling the whole story.
That's a great way to think about it, yes.
Making smart, statistically sound guesses based on what you do know, even when you don't know everything, seems like a crucial tool, not just for building the models, but for actually trusting their predictions when you're dealing with sparse data.
Absolutely critical.
All right, finally, let's pull back and look at the grand vision, the tangible impact of AI. Our last track today is Coding on the Island. Hey, this song gives us this potent sense of the boundless ambition, the global reach of these digital creations. How a focused beginning can lead to really widespread influence. It paints this picture. Upon the island where the sun stay high, quoting rhythm watching multiply, metrics dancing, numbers don't lie. From a small spot, we touch the sky. And then the call. Launch the signal. Let it gleam. Reality now feels like a dream. It's a powerful story, isn't it? From a few lines of code to genuinely transforming real-world experiences.
It really is. And connecting this to the bigger picture, Coding on the Island beautifully captures that whole journey of AI development, from focus creation to global deployment. That small spot or island, it represents the intense, often quite isolated effort of development, the research labs, the late-night coding sessions, but the ultimate goal is almost always to scale up and have a global impact. And this leads us right into the critical field of MLOps machine learning operations. MLOps deals with all the engineering challenges of taking an AI model from just a prototype to running it reliably in production, at scale, and keeping it running well.
Right, the less glamorous but essential part.
Exactly. The song mentions metrics dancing, numbers don't lie. Once a model is deployed, the real challenge becomes continuous monitoring. You have to watch out for things like model drift. That's where the model's performance degrades over time because the real-world data it's seeing starts to change. Or data quality issues cropping up. We use techniques like A/B testing constantly, comparing new model versions against the old ones, making sure any metric lift actually translates into real user benefit. The idea of reg now worldwide, reg come alive, catch the V that speaks to the widespread adoption, sometimes the viral potential of successful AI. This is where the binary beats that stream really transform into tangible solutions, making reality now feels like a dream for users all over the globe. It's not just about building the model, it's the entire life cycle, keeping it effective, keeping it fair, keeping it performant in a world that's constantly changing.
That's such a powerful reminder that the deep dive into AI doesn't just stop when the model is built, it carries on through its entire operational life. It's truly amazing to trace that journey from those initial island roots of focused development through all these complex challenges we talked about today, to ultimately influencing the world in these profound ways. Wow, what a deep dive that was into data roots, Rasta Rhythms. We've explored the immense, complex challenge of data hunger, getting into not just quantity, but quality, diversity, even the environmental costs. Then with Tweakin the Tokens, we really ventured into that painstaking world of iterative optimization, grappling with non-convex landscapes and hyperparameter tuning. We saw the power of collective intelligence and mixture of experts. understanding how specialized models can help scale AI much more efficiently. We navigated uncertainty with smooth divide right, uncovering those clever statistical tricks behind robust probability estimation, especially with sparse data. And finally, with coding on the island, we zoomed out to appreciate that whole ambitious journey from focused development to global deployment, with all the MLOps complexities involved.
Yeah, these tracks really do capture the spirit of AI development, I think. It's a field that's defined by both these immense technical challenges and, at the same time, this profound aspiration. It's a journey filled with continuous, dedicated effort, researchers constantly pushing boundaries, solving problems that might seem intractable, all to make intelligent systems that truly make a difference in, your daily life. It really is about turning those binary beats into a kind of heartbeat song for the world.
So as you interact with AI every day, maybe it's recommending your next song, maybe it's power your navigation app, what unseen challenges do you think went into crafting that experience? And what islands of focused development do you imagine are still out there right now, innovating towards the next signal that will make reality feel even more like a dream? That's all for this deep dive. We really hope you enjoyed this unique exploration of AI through music. Till next time, keep digging, keep learning, and keep questioning.